Hello friends, good evening all of you. So today's session we are going to see about revisions about previous year questions. Actually, I've taken the last videos, everything. It's a topic wise syllabus full and full. Maybe it will be getting a little bit more also because we have to know full and full PYQs only. It's very important. Now just you can take NET exam, SET exam, any competitive exams. We need to cover full and full PYQs, previous year questions. I told you already we have to see minimum 5 years of question papers. Yes. So depends on the cause this one. So actually I have just have started today. Just we can see the previous year questions. Apart from syllabus, we have just looked on it and some of the syllabus and from this one. Just we can see the previous year questions. The questions depends on that we can see the topic also. It will be best to know the topic, keywords and definitions as well as we can understand how we are going to answer the question also. Okay, it will be very interesting, I think so. That's why just we can move on to this pattern also. And okay, we can see now. First, let me start. First one, you can see given below are two statements. First statement, hardware control unit can be optimized to produce fast mode of operation. What is the second statement? Indirect addressing mode needs two memory reference to fetch operand. Yes. So here, what is the answer? Before saying that, just we can see. First one, what is control unit? We have to know for this question, what is control unit? What is hardware control? What is microprogrammed control? And apart from that, addressing modes also we have to know. Yes. Now we can see control unit actually components of what will go. Control unit control the and coordinates the all the operations of the computer. So it generates control signals to direct the ALU registers, memory and input devices. Just it will give signals or whatever what it has to do, next what has to do, it will give signals. That is called control unit. So there are two types of control units, hardware control and microprogrammed control unit. First one, what is hardware control? The hardware control unit generate control signals using fixed electronic circuits like such logic gates, decoder, multiplexers and flip-flops. Since the control signals are generated directly by the hardware, no control micro instruction needed. That is very important question. Actually, the keyword fixed electronic circuits also. So that's why I have given the keywords, a very important keywords. Actually, I have given in the characteristics. This is a few uses fixed electronic circuits and no micro instruction needed and very fast execution, difficult to modify but mostly used in RISC processor. So we have to know here what is CIS, RISC processor, what is CISC processor also. That we are going to see next slides. Okay. Okay, next one, microprogrammed control unit. A microprogrammed control unit generates control signals using micro instructions stored in control memory. That's all called ROM or ROM or firmware. Instead of hardware logic generating every signal, it first reads a micro instructions from memory. So what are the characteristics? So here uses control memory, easy to modify and flexible and slower than hardware control and mostly used in CISC processor. So it's very important question. What is RISC and what is CISC processor also? Okay, now we can what is RISC processor? RISC stands for Reduced Instruction Set Computer. In Reduced Instruction Set Computer architecture, the instruction set is computer. It's a simplified to reduce the execution time. So RISC is a small set of instruction which generally include register to register operation. So that's also one of the keyword that is called small set of instruction we'll use in the RISC. Thus, data is stored in the processor register for for computation, and results of the computations are transferred to the memory using store instruction. So all operations are performed within the registers of the CPU. RISC instructions have simple register addressing and hence use less number of addressing mode. That also important keyword. RISC uses relatively a simple instruction format and easy to decode. Here the instruction length can be fixed align on word boundaries. RISC processor can execute one instruction per clock cycle. So these are the very important keywords. So this is done using pipelining method, which involves overlapping the fetch, decode and execute phases of 2 or 3 instruction. So what is pipelining? Actually, pipelining, I'll tell you only one thing. Here it will come, it will work out the multiple process at the same time. That we are going to see separate concept here in itself. While seeing the question itself, we'll see what is pipelining, what are the types of pipelinings we have, everything we can see. So the RISC takes relatively a large number of registers to process and it takes less time to execute. Compare than ICASC. So again, I'll tell you whatever features and whatever characteristics we have given, that is the keywords only, it's very important. So there are various features of that is RISC processor. It's a relatively few instruction and relatively few addressing modes. It is used for memory access limited to load and store information. All operations are done with the registers on the CPU. It is fixed length and easily decode and the format. Used for single cycle instruction execution. It is can be hardware rather than microprogrammed control. Okay, so next one, CISC processor. CISC stands for Complex Instruction Set Computer. It comprises a complex instruction set. It incorporates a variable length. What happened there? RISC, that's fixed length. So here variable length instruction format. It requires register operands can only 2 bytes. So the instructions require 2 memory address. It can take 5 bytes to include complete instruction. So the CIC has a variable length encoding of instruction and execution of instruction may take a varying number of clock cycles. And CIC provides direct manipulation of operands. Okay, that is actually it's enough. Example, the add instruction you can take will use index addressing to specify one operand in memory and direct addressing to specify the second operand in memory. So the instruction would use another memory location to store the result. So like this they are giving. So that's instruction with 3 memory references for execution. But many CASC architecture, actually what happened, there are 3 memory references we have used. But many CASC architecture read the inputs and write the outputs in memory location instead of register file. So on CASC architectures take a large number of addressing modes, more hardware logic is required to implement them. But this reduces the computation speed actually. Okay, features of CASC. There are various features of CASC process. A large number of instructions, typically from 100 to 250 instructions. Some instructions perform a specialized task and are used to infrequently. And a large variety of addressing modes, typically from 5 to 10, 20 different modes. A variable length or instruction formats. Okay, so from this concept, we can see the question. So here the hardware control unit can be optimized to produce a fast mode of operation. Actually, yes, correct. This is fast mode of operation is a hardware. So the statement will be correct. First one. The indirect addressing mode need 2 memory reference to fetch operand. So we are going to see now what are the addressing modes. Actually, indirect addressing modes to need 2 memory references because indirectly they will go one address to that one. So indirect addressing modes we need. So both are true only. Now we can move on to the next question. You can see here, this also important. Every topic I used to give, you know that table we will give. Just using this one. How long I've have told informations. The same thing, just we kept in the table. That's all. It will be very useful. All topics maximum I will give. The topics just you can read in the before exams. It will be it will be good because no need to work or read everything. Okay, now we can see what type of addressing mode, less number of memory references are never required. Actually, immediate also, implied also we can say, because I'll tell you what is this. What is first one, addressing mode? An addressing mode is the method used by the CPU to determine where the operand data is located to find that we are using addressing mode. For example, add A comma B. So the CPU must know where A and B are stored. So that is called. This may be inside the instruction, inside a register, in memory, and calculating index register, whatever. So to find the operand where it has to store, actually, that is called addressing mode. First types of addressing modes. First one, immediate addressing mode. So here what the operand actual data is stored in the inside instruction itself. So here nothing, no need to access memory also. So here move R1 has 25 means directly it will go here, no memory reader. So what happened? No need memory means what questions actually there? Which one is less memory needed? So here no memory needed also. So immediate also we can say. And register also, register, it will take CPU registers. Here also no memory is accessed here. The operand stored in the inside the CPU register. So now you can see add R1 comma R2. R1 is a R1 register, R2 register. So this both are we are using CPU register only, it's not a memory. Direct addressing mode. The instruction contains memory address where the operand is stored. For example, load 500 means memory where 500 is 75. 500 in the memory 75 data will be there. So CPU goes directly to the memory 500. Indirect means what happened? So here the instruction contains the address of the another memory location. So again I'll tell you the instruction contains the address of the another memory location which stores the effective address of the operand. So here one memory actually what this load 500 just I'm giving. What will happen? The CPU first read the memory 500 from the other memory that is called 800 to obtain the effective address. Then access memory 800. So there 75 to fetch the actual operand. So here we are using that as another one memory to another memory location. So that is called indirect addressing mode. And indexed addressing mode. Indexed means what actually? Indexed means some key word like this we can say. One, for example, index book, page number through that we can go. The effective address is obtained by adding index registers value to the address given in the instruction. Effective address equal to what? Address plus index register. Now we can see load 500 of R1 register. Suppose R1 equal 20 means that we will add this actually formula. So address 500 plus index register 20. This is 520. Memory will be in 520. The 90 will be loaded. So instruction word you can see 500 R1 means that CPU adds the index register value R1 to 20 to the my 500, giving the effective address 520. So in the 520 equal to 90 to fetch the actual operand. So only one memory reference is required to obtain the data here indexed. And implied addressing mode. So implied means the operator is not mentioned in the instruction. So here CPU already knows where the operand is. So CMA means automatically it will take the accumulator. So say clear A means clear accumulator. So here accumulator is implied actually. So we can say actually from that point of questions we can say maybe immediate or implied or register also. These three things is a less memory needed. Some questions they will ask you like this also because the questions different questions also maybe the answer will be there. So that type of questions they will give you mark 5. So here I have given addressing mode, operation operand location and memory references. So immediate means inside instruction, implied means implicit accumulator or register, register means CPU register. So this both the three things no need memory actually memory references. So direct means memory, one memory needed. Indirect means memory through another memory location, two memories needed. Indexed means actually one only memory equal to address plus index register. Okay, so this is a concept actually. It's a very important concept today. What we have seen with question, we have said actually what is a control unit, what are the types of control unit, and what is CISR AC processor and addressing modes also. Okay, I hope it's clear. Okay, tomorrow next video we are going to see very interesting weekly ones. I thought to take it how we are going to take syllabus, take notes or whatever even net content also to use AI tools because through full and full net concept yeah, I'm taking. So for example, in ICT paper also it's asking AI teaching based questions and AI tools also they are asking what are the AI tools using for that one also the ICT paper they are asking one question. So that it's very interesting and it will be not only net paper, it will useful for those are teaching they can take notes and everything. It will be very interesting that one that video. So I thought weekly ones at 2 weeks once we can add AI tools based content notes, content creating and taking questions or everything we can see. So we can see next video this AI method. Thank you all of you. Thank you once again.